Here is for geometry, notes 13, section 2.5, and the topic is reasoning using properties of algebra. Make sure you put your name, the date, and the class period you're in. And our essential question is, how do you solve an equation? And the answer is, for solving an equation, is you take step by step to simplify, doing inverse operations, and then you have to explain each step using the properties that are below here. And in the next section here, I filled all this in because it's very, very crucial you keep it straight. When you are dealing with adding, subtracting, multiplying, and dividing, substitution, distributive property is all of these things on the side. You're going to be relating to these like crazy whenever you're doing operational changes, which is called the inverse operations, which would be adding and subtracting, multiplying, division. Those are inverses of each other. And when you're replacing something, you're going to be using substitution. I like to put that on here also because that's like one of my favorite words for substitution is to replace. So I'm going to write it over here on the side if my pen will work. Okay, I'm going to write the word replace over here on the side for substitution property. Remember, distributive property is just where you multiply it into the parentheses and it distributes the A onto both items inside my parentheses. When we're dealing with geometric items, such as segments or angles, we have a reflexive property of equality, we have a symmetric property of equality, and a transitive property of equality. We have three different types of properties. Inside these things, the segment length, when we say it's actually reflexive to each other, means it's actually equal to each other, so it has to be written exactly the same on both sides, like a reflection in the mirror. So we have AB equals AB. With angles, we'd have angle A is equal to angle A. It has to be identical on both sides for it to be reflexive. With the symmetric property, to be symmetric means it's equal on both sides, or the two sides are equal to each other. If you're just dealing with numbers, that would be A equals B, and then you can flip it and B equals A. This is called being symmetric. It's kind of like the commutative property, where you flip-flop it back and forth. If you're dealing with segments, it says AB is equal to CD. Then you flip the order, CD will be equal to AB. It flips it. Is a symmetric property. Once again, angles. You have angle A is equal to angle B, so flip it, and it'd be angle B is congruent or equal to angle A. I say this is just flipping, or what you should have heard before is the commutative property. This pen is terrible. Alright, on transitive, this one is traveling property. Typically it is one of the most difficult for students to follow, but it has, for the real angles, it has A is congruent to B, then B is congruent to or equal to C, then the result is that A, which was here in the beginning, will be equal to C, which is this end part. So basically they ignored the B's and said that A was equal to C. That's for numbers. Same thing will happen with segments. If I have segment AB is congruent to segment CD, then segment CD is going to be congruent to EF. The result is going to be that AB is equal to EF. So basically the CDs are erased. And then with the angles, I have measure of angle A is equal to the measure of angle B, and the B is equal to the measure of angle C. Therefore, measure of angle A has to equal the measure of angle C by the transitive property. Okay, in our examples now, our examples are going to be set up in two-column proofs. A proof is a logical argument that is made up of statements and reasonings to come to a logical conclusion at the end. If I set this one up, here's just dealing with algebra, since this lesson is reasoning using properties of algebra. This first one, I want to solve this problem. In a two-column proof, I have many steps that I have to do to actually solve this problem. The very first one, always over here, is that you have your actual question written, what it is you're looking for in an actual algebra problem, and that is what is given to you. So this very first reason over here on the side will always be the word given. Now, if I was going to solve this problem, I'd have to get rid of the parentheses, which means I would have to multiply 3 times x and 3 times negative 2. Well, that becomes 3x minus 6 is equal to x plus 4. So this process of multiplying 3 into my parentheses is called what property up here? Which one of those properties multiplies into the parentheses? Well, this is going to be the distributive property. Alright, if I look at step C, I want to look at what would I actually do next to solve this problem. And I notice that I have an x on each side, so I will typically take the x on the left side and bring it over to the right, or I'm sorry, on the x on the right side and bring it over to the left side. And since this is a positive x, which is understood 1, that means I would be subtracting it from the 3. So if I was writing this on an actual piece of paper, because we don't show all of the math in a proof, I would actually subtract the 1 from the 3 and end up with 2x minus 6 is equal to 4. Now, this operation right here of subtracting 1x is my reasoning that goes in the C, that goes in the C blank right over here. I did the subtraction property, where I subtracted the same item from each side, which I did. I subtracted 1x. So in my C blank, I write the subtraction property. Okay, now to go to D. I'm looking at my problem, because now, let me rewrite it here. And I have the x all by itself, but now I need to move the 6. To move the 6, I'm actually going to add 6 and end up with 10. So on D, I'm going to put 2x equals 10. My step over here, or my reason, well, if I look at what I did, let me get my red thing going. Right there, I added 6 to both sides. That means this step right here is the addition property. Okay, and now if I'm at my problem, I would next divide both sides by 2 and end up with x equal to 5. And this is the division property. Okay, I have solved it, and I actually did not need this extra step. I was guessing when I made your table on your notes at how much you would need, and you don't need that extra step. Okay, let's go to number 2. Here it gives you 2x plus 10 equals 7x, so the a over here on the reason sides has to be what? Has to be the given. That's what's given to you. It's your problem. Alright, if I'm going to solve this, I'm going to look at the fact that the 2x is on the left side and I need to move it over here to the 7x. So if I was working this problem over here on the side, I would subtract 2x and end up with 10 is equal to 5x. So that's what I'm going to place on B. And then the reason, well, what did I do? Okay, if I'm looking at it, I did the subtraction property. Okay. And now if I'm looking at my problem, next would be to actually divide by 5 on each side, which gives me 2 is equal to x, would be my C blank. Oops. And this operation that I did right there is division. Okay, and then this one actually has one more step, I realize. Once again, I was just guessing at how many steps you would need here. And because this is actually written backwards, I need to actually flip this around so that I have x equals 2 in the proper order. Now when I flipped it, which one of these properties allowed you to flip things? Was it the reflexive property, the symmetric property, or transitive? Well, right there I have it written. Flips the order is the symmetric property. So your last statement here is your symmetric property. Okay. On the next problem, example number 3, is a few statements here that say name the property equality of that what is listed or illustrated. It says if wx is equal to yz, then yz is equal to wx. Well, what's happening? Here's the wx and there's the wx, and then the yz and the yz. What is actually happening, I see it, is it is flipping the order in which you are writing it. Because the wx was first, it becomes second. Yz was second, it becomes first. So that means this is the one that flips the order, flips it around, and makes it symmetric. Okay, symmetric property of equality. On the second one, it says D, measure of angle D, is equal to the measure of angle E. Then the measure of angle E is equal to something totally different, a number. And then it comes back to saying that D is equal to your number that you had. Now, I'm looking at what we're given, and typically students will mislead this one because it looks like all they did was cover up these two items and said that D is equal to 45, which means it would be the transitive property of equality. And if this was an angle here, an actual like measure of angle F, then that would be true. The problem is that this is actually equal to an actual number. This is not the same as the measure of angle E notation, because this is actually saying that E is equal to a number 45. So whenever it says D, the measure of angle D is equal to 45, this is actually replacing into my first statement. It's replacing what the measure of angle E actually was, which was 45. This is an actual replacement because 45 degrees is not another angle. To use the transitive property, you must have all the same type of items. You can't change and go to segments or go to numbers. It has to all be angles, or it has to all be segments, or it has to be all be numbers. It can't mix between the two different types. If it is replacing, that means this is substitution. Replaces an item. Okay, substitution property of equality. Alright, on our last example here, it has example 4, and here's a segment given to you, and up here at the top it says that wy is equal to xz, which is here on my first line. We're trying to show that wx is equal to yz, which is my last step down here. This is what I'm trying to prove. On my picture, I'm going to go ahead and say wy, we know that this is going to be congruent to this. We know those two parts are congruent. Anything that is given to you in the very beginning on A is marked given. Now, next, I'm looking at B and C together, because B says I'm calling for the segment addition postulate. Remember, segment addition postulate is where you take your two small pieces of a segment, add them together, and it equals the larger segment. So B is saying I want to take two small segments, add them together, and make them equal the big one. Well, wy, if I look at this first one, wy, two smaller ones, which is wx and xy. It has two smaller segments. So I'm going to say that wy is equal to wx plus xy. Those pieces. On C, they say that xz is equal to xy plus yz. Those two parts. Well, these are two small segments added together to equal to the big segment. So over here is once again segment addition postulate. Now my next step, it says wx plus yx. Where is that above in my proof? Wx plus yx is right there. Okay. Then, need another highlighter. I don't have one. This says it's equal to wy, which is right here. I need something on the other side. It says on the other side of my equation, since wx plus xy is in B, which then tells me that yw or wy should be equal to xz, I know that xz is equal to this. That means I have xy plus yz. Let that sink in. I know right here I have these two things are equal to each other. I know that wy equals this, so I'm taking this item and replacing it into that first position. I know that xz equals this one, so I'm taking that information and replacing it here. And when I rewrite it, it looks like this. Okay? Alright. Now I've got to get to wx is equal to yz. Now, if I'm looking at my two segments that I have on D, I do notice something, and that is I have XY on both the left and the right side. So if I actually subtract that out, if I show it over here on the side, if I subtract an XY and I subtract an XY from both sides, they go out. Oh, sorry. They disappear, and all I'm left with is WX is equal to YZ, which is what is there. This operation that I did right here was I subtracted the segment. So in my reasoning, is my subtraction property of equality. Alright, got to study this one. This one's the tricky one when you get with the geometry shapes to see what was happening, because it pull all the numbers away. Okay, make sure you answer your summary question for me in class, and I'll have another example similar to this in class to go over to see if you grab a hold of what's taking place.